Hello everyone, so in this video we are going to solve a question of LeetCode, that is lowest common ancestor of a binary tree. So let's start with a problem statement. Given a binary tree, find the lowest common ancestor, that is LCA, of two given nodes in the tree. According to the definition of LCA on Wikipedia, the lowest common ancestor is defined between two nodes P and Q as the lowest node in T, that is both P and Q as descendants, right? So basically the lowest common ancestor is defined as a node which is nearest to both the nodes between the nodes which we are finding the LCA, right? So let's say in the first example we need to find out the LCA between 5 and 1. So for this 5 and 1, the nearest node to 5 and 1, right? The nearest parent node to 5 and 1 is 3. So we will be doing 3 in this case, right? So let's quickly see the first example. So in the first example we have this binary tree. So for this binary tree, if we want to find out the LCA of, let's say we take LCA of 6 and 4, right? We need to find out the LCA of 6 and 4, let's say. So for this 6 and 4, if we find out the common parent node, right? So let's say for the 6 and 5, the lowest common ancestor or the nearest parent node, the nearest common parent node is 5, right? So we are just returning 5 in this case, right? So this 5 is the lowest common ancestor in this case. Similarly, if we see for any other one, like in the first example we have already seen for 5 and 1. So for this 5 and 1, the nearest one is 3, so we will be returning 3 in the first example, right? So I hope the example is clear to you. Let's see how can we approach this question. So there are multiple approaches to solve this question. So we will be starting with the very basic and the brute force approach. So the brute force approach to solve this question is, let's say we are just first finding out the path from the root to that node, right? So let's say if we find out the LCA of 6 and 4, so first we will be finding out the path for 6 and 4. So for 6 we get path 3 to 5, then 5 to 6. So this is the path for node 6. So for node 6 we get path 3, then 5, then 6, right? Similarly, for node 4 we get path 3 to 5, then 5 to 2, then 2 to 4, right? So this is the path. So for this, let me write the path again here. This is 3, so the path for this should be 4. So the path for 4 is 3, then 5, then 2, then 4, right? So this is the path. So when we see from the rightmost side, the common nodes which we can find out is 5, right? So this is the 5 is the common node. So we can easily see this 5 is the common or the nearest parent node from for 6 and 4. So we can consider 5 as the lowest common ancestor, right? So I hope this brute force approach is clear to you. So this brute force approach is taking a time of big O of n, right? This is taking the time of big O of n because in the worst case we will be traversing through all the n nodes, and the space complexity would also be big O of n because we need to store this path in some vector or an array. So this will be taking around big O of n space, right? So to reduce this space complexity, we can use a DFS approach. In that DFS approach, we will be just manipulating few statements to get this LCA easily, right? So let's see how can we approach this question through DFS approach. So in the DFS approach, what can we do is, let's say we need to find out the path for 6 and 4. So we start the DFS from root, right? So we can either go to left or right. So we start from left. So when we go to left, we go to 5, then we go to 6, right? So whenever we encounter a element or a node which is equal to any of our given node, right? So for that case we will be returning that node from here. So let's say we return 6 from here, right? Similarly, we go to right part, then this and this node. So for this 7 we will be returning null because this 7 is not equal to any of the node, but for 4 is equal to one of the node, so we will be returning 4 from here, right? So 4 is written from here and again from here. So for this 5 we get both the nodes as not null nodes, right? We are getting both the nodes as not null node. So in this case we will be returning 5, right? We will be returning 5 because 5 is the node where we are getting the not null nodes. It means 5 is the nearest parent node to, or we can say nearest common parent node to both the nodes, right? So I hope the approach is clear to you. So for this approach it will take around time complexity of big O of n, and the space complexity is also big O of n, but the space complexity of this approach and the space complexity of brute force approach is different, because in this DFS approach this big O of n is the recursive stack, right? This is a recursive stack and it is an auxiliary space, so this is much more efficient than the brute force, right? Because in the brute force we are taking an array, but in this is a recursive stack, so it is internally optimized, right? So yeah, this is fine, I guess. Let's quickly move to the coding part. So let's first check if we encounter any of the element, right? So we are just writing the statement to return from here. So let's write if root is equal to null, or root is equal to p, like p is a node given to us, or root is equal to q, right? If any of the condition is true, then we will be returning root from here. Else let's move to left or right. So let's write tree node left, and we will be calling this recursive. So let me just copy it from here and paste it here. Let's remove this. Yeah, and let's call this for left, and similarly let's call for right. So let me just copy this statement here, and this should be right, and this is right. Alright, so now let's check if left is equal to null, right? So in this condition we will be returning right, and if right is equal to null, then in this case we will be returning left, else we will be returning root, right? So let's see why we are writing these three statements. Let's say for any of the node, right? For any of the node, let's say we are here, right? For in this case, let's say we get a node as null from here, and any of the node which is not null from here, right? Not null from here. Let me write not null. So in this case we will returning this node, right? Else if this is null, right, this is null and this is not null, so we will returning this node. Else if both the nodes are not null, right, if both the nodes are not null, then in that case we will returning the root, right? Like we have already seen in the first example, this is returning 5 and this is returning 1, so in that case we were returning 3, right? That is the root. So I hope this is clear to you, and let's try to run this on a sample test cases. Yeah, this should be else if. Yeah, this should be fine now. Yeah, it's working fine, so let's just submit this. Yeah, it's working fine. So the time complexity for this solution is big O of n, and space complexity is also big O of n, right? So I hope you understood the solution and the approach. If you still have any doubt in this question, feel free to comment it down. Please like this video and subscribe to our channel. I will see you in the next video.